A fingerprint in the sky, 1 part in 100,000. Those tiny ripples kept the universe from tearing apart. They let gravity sort matter, while expansion spread the mess. Immediate takeaway: order survives because rules and feedback curb chaos. Picture waves freezing into a quiet cosmic blueprint. That blueprint guided gas, stars, and galaxies into place. Without it, space would be uniform fog or violent clumps. Instead, we get durable patterns, not raw pandemonium today. Today, we trace the quiet tricks enforcing order. By the end, the night sky feels engineered, yet natural. You drift along a faint silver bridge between galaxy clusters. The structure looks like lace, stretched across an endless dark sea. Here is the quiet rule behind that grace. Symmetry creates conservation laws that box chaos into corners. When time looks the same tomorrow, energy stays accounted for. When space looks the same everywhere, momentum cannot just wander. When direction has no favorite, angular momentum keeps spinning steady. These constraints are the universe's seatbelts and guardrails. They narrow possible motions and filter out wild paths. Rule of thumb: conserved quantities are nature's most stubborn habits. How does that stop a collapse into noise? Motion becomes predictable because allowed changes are paired with costs. You can't spin up a planet without spinning something down. You can't shift a galaxy's center without trading momentum elsewhere. Noether's insight ties symmetry to bookkeeping with elegant force. That bookkeeping hard limits how far chaos can spread. Example: in real terms, Earth keeps a stable path. It orbits near 30 kilometers per second, year after year. Our galaxy's disk also holds shape, near 220 kilometers per second. Stars wobble, but the disk persists thanks to angular momentum. Net result: symmetries prune possibilities until structure can last. Now watch two galaxies tug while the background quietly stretches. Gravity pulls together, while the Hubble expansion pulls apart. That tug-of-war plays referee for cosmic structure. Hubble's number sets the pace, about 70 kilometers per second per megaparsec. Expansion cools and dilutes, so gravity fights on fair terms. When gas gets dense enough, a tipping point appears. That point is the gene's threshold, where collapse can start. As collapse deepens, orbits scramble, then share energy through encounters. Systems settle by virialization, balancing motions against binding pull. That balance makes halos stable bowls, not exploding pots. Example: in real terms, the Milky Way's halo weighs enormous. Think near 1 trillion suns, wrapped in a dark cocoon. Typical stars speed around near 220 kilometers per second. Hot halo gas reaches a few million degrees Kelvin. Despite that frenzy, the bowl holds shape for billions. One sentence recap: expansion and gravity co-manage order at scale. Shift to a boiling texture on the sun's bright face. Order appears as tiled cells, each a rising hot plume. Entropy still climbs, yet pockets of order pop up. Here's the trick in plain words, short and honest. Open systems build structure by dumping waste into surroundings. Energy flows create gradients, and gradients drive organized motion. Whenever heat can exit fast, patterns bloom to move it. Convection rolls, jets, and waves act like heat highways. They look delicate, but they are ferociously practical. The sun's granules span about 1,000 kilometers across, forming carpets. Each cell lasts minutes, then fades as heat escapes. On Earth, sunlight powers near 170,000 terawatts of outflow. That flow lets storms self-organize, while the planet still warms. In galaxies, radiation escapes while gas cools into stars. Feedback rises, but the heat can radiate to space. So structure forms while entropy keeps score, unbothered. One sentence recap: gradients pay for pockets of order. Breathe the cold night beside a silent radio array. Above you hangs a mottled microwave afterglow, almost perfectly smooth. Inflation set that stage by stretching space absurdly fast. Define it simply: a tiny instant of runaway expansion. That burst ironed wrinkles flat, then froze gentle ripples everywhere. Those ripples came from quantum jitters, stretched to cosmic scales. They seeded wells where later galaxies would calmly gather. We can measure the imprint with stunning precision today. Temperature wiggles land near tens of microkelvin across the sky. The contrast is roughly 1 part in 100,000 overall. Patterns peak near a degree, tracing sound waves before decoupling. The spectral slope sits just shy of perfect scale freedom. Numbers aside, the message feels beautifully calm and controlled. A smooth start left the universe predictable, yet fertile. Example: in real terms, galaxy clustering echoes those frozen tones. One sentence recap: inflation pre-tuned randomness into a workable blueprint. Float far above a giant galaxy with twin blue jets. The core engine is messy, but the outcome is tidy. We mean feedback, where output throttles the input that feeds it. Bursts of newborn stars throw winds that rattle leftover gas. Supernovae punch holes, heating clouds that would otherwise collapse. A monster black hole can do the same, but louder. Jets carve bubbles, stir halos, and throttle fresh star formation. The aftermath looks chaotic, yet the net effect is steady. Cooling tries to race ahead, heating drags it back. Galaxies land near a moderate pace, not a runaway sprint. Typical big spirals form a few suns per year. Clusters show hot atmospheres kept just on the edge. You even see ripples like sound waves in X-rays. The Perseus cluster wears circular scars, spread by central outbursts. Example in real terms: throttled inflow keeps disks long-lived. Bottom line, feedback loops keep galaxies from boiling over. Glide behind a compact red star, watched by a chain of worlds. Each planet tugs neighbors gently, settling into repeating timing patterns. That lockstep is resonance, the metronome of orbital stability. It matters because near misses can last, while crashes cannot. Resonant timing keeps close worlds from sharing the same street. The trick is simple: gravity trades kicks in rhythm. When kicks align, small nudges add and big risks fade. Jupiter's moons offer a clean, numerical example to trust. Io, Europa, and Ganymede click in a 1-2-4 cadence. Their angles precess, but the pattern keeps tides predictable. Farther out, Pluto and Neptune dance in a 3-2 exchange. Despite crossing longitudes, their timing prevents dangerous meetings forever. Compact exoplanet systems often show similar resonant necklaces. TRAPPIST T-1 displays a graceful chain of near-commensurate beats. The system persists for eons, despite tight spacing between orbits. What to remember: resonance fences chaos into narrow lanes. Dust floats through a nebula, catching a single spear of light. You blink, and every grain looks solid and classical. Yet the building blocks under it all behave quantum strange. The calm you see emerges through a rapid forgetting. That process is decoherence, where environments shred fragile superpositions. It matters because macroscopic order needs robust, trackable states. Collisions, photons, and fields entangle systems with countless tiny details. Phases wash out fast, so weird interference fades to silence. What remains are pointer states, which resist everyday disturbances. Numbers help: a dust grain in air decoheres absurdly fast. Think around 10 to the power of -31 seconds. Even in space, weak sunlight and gas settle phases quickly. A mirror's vibrational mode also decoheres on short timescales. The everyday world keeps forming because noise erases quantum weirdness. So the picture is: classical calm rides quantum forgetting. Step back to the whole cosmic web, glowing like city lights. We started with a 1 in 100,000 fingerprint. That tiny pattern, plus rules and feedback, kept order alive. Conserved quantities narrowed options, so motion stayed trackable. Expansion and gravity co-managed growth like a steady thermostat. Gradients powered pockets of order without cheating entropy's arrow. Inflation smoothed the start, freezing useful ripples across space. Feedback throttled galaxies, so nothing boiled into a frenzy. Resonance fenced orbits, letting crowded systems hang together. Decoherence hushed quantum noise, revealing a stable everyday stage. The net result: patterns win more often than Pandemonium. If this deep calm surprised you, consider sticking around for more. Subscribe if you want curious order appearing in your feed.